Find the force of a 0.180 kilogram particle that moves along an x-axis according to this function. X with respect to t equals -13 plus 2t plus 4t squared minus 3t cubed at time 3.5 seconds. So let's have the given from this problem. So the givens are the mass of the particle. Mass is equal to 0.180 kilogram, and then we have the position function x equal to -13 plus 2t plus 4t squared minus 3t cubed, and we're also given the time equal to 3.5 seconds. Now we are required to get the force being exerted on the particle when the particle is moving along the x-axis as given by this function x at time 3.5 seconds. Now if we will remember our previous lesson on kinematics, now we can get the acceleration of this particle so that in our solution we are being asked to find force. Force is mass times acceleration. We already have mass. We need to look for the acceleration of this particle. Now, given the position function, we can get the acceleration of this particle. Now, to get the acceleration of this particle, we just need to differentiate that function, that position function, because we know that velocity is dx over dt, the derivative of the first derivative of the position function with respect to time. But the second derivative of this position function x is the acceleration, because acceleration is dv over dt, the derivative of your velocity with respect to time. Actually, this is the second derivative of our position function. But let's do it one by one. Let us first get the velocity function of this given position function of x. So we have v equal to dx dt, the derivative of our function. So our function is -13 plus 2t plus 4t squared minus 3t cubed. Okay. Now, deriving this position function, we will arrive at the velocity function, which is equal to 2 derivative of 13, since it is a constant, is 0. The derivative of this term 2t will just be equal to 2, plus the derivative of this term 4t squared will just be equal to 8t. Okay, remember your calculus. Then the derivative of 3t cubed is equal to 9t squared. So this is now the velocity function. So for us to arrive on the acceleration function, we need to again derive. We need to again apply differentiation on this velocity function. So acceleration is dv over dt, the derivative of the velocity function 2 plus 8t minus 9 t squared all over dt. So the same, applying differentiation, this term 2 will just be 0. The derivative of 8t with respect to t will be equal to 8, and the derivative of 90 squared, negative 90 squared, will be equal to negative 18t. So this is now our acceleration function. So to get the value of this acceleration, we just need to get the instantaneous acceleration at time equal 3.5 seconds. So to get the instantaneous acceleration, we just have to substitute this time on our acceleration function. So therefore our acceleration will just be equal to 8 minus 18 times 3.5 seconds. Our acceleration will be equal to 8 minus the product of 18 times 3.5 seconds. This is equal to negative 55 meters per second squared. Negative 55 meters per second squared. So this is now our acceleration. We can just easily substitute it in the force equation. Force is equal to mass times acceleration. The mass is already given. The mass of the particle according to the given is 0.180 kilogram. So the mass is 0.180 kilogram times our acceleration, negative 55 meters per second squared. So the force being exerted on that particle traveling on the x-axis given that function at time 3.5 seconds will be equal to 55 times 0.180. This is equal to negative 9.9 Newton. Negative 9.9 Newton. So by magnitude, it is 9.9 Newton. So the negative sign just denotes the direction of this force, which is also negative. The same with the acceleration. The answer is negative 9.9 newtons.